Hello everyone. Today we will be discussing August lead coding problem number 3, that is power of 4. So given an integer and we need to find if the given integer can be represented as a power of 4. So if it can, we just have to output true, and if it cannot, then we have to return false. So 16 is a power of 4, 4 into 4 is 16. 4 square, so we output true, and 5 cannot, so we output false. And there's a one follow-up question: if we can solve this problem without loops and recursion, then we have to implement that solution as well. So first we will discuss a naive approach in which we uh, generally solve this problem in O of log and time complexity. So I will discuss 4 solutions, out of which 2 will be based on loops and 2 are without loops. Okay, so 4 solutions, 2 will contain loop and 2 will without loops. Okay, so let's proceed. So the very basic solution we come across is the divide approach. Okay, so what we just do is just store this number in a temporary variable and take a count, and while this number is greater than 1, we divide this number by 4 and count plus plus. Okay, and if the power uh, 4 to the power count is equal to the original number, then we return true and else false. So let's check on both the test case 16 and 5. True and false. Submit. Accepted. And now we'll discuss the same logarithmic approach, but with some trick of bit manipulation. So let's iterate from I equals to 31st bit to I equals to 0th bit. Okay, and check if that bit at ith position is set or not. So take the power of 2 and AND it with num. Why we are doing it? Let's say we have a number 7, okay, and we take one, like we are at second position. So 2 to the power 2 is 2 to the power 2 is 4. So the binary representation of 4 is this. So if we AND this 1 with this given number, we will get 1, because 1 and 1 is 1. So that means that bit at ith position is set. Okay, so that's why we are doing this. So if this bit is set, we just count plus plus, and if we look at the binary representation of any power of 4, let's say 4 equals to its 100. For 16 it will be 1000000. For 64 it will be 1000000. So if we look carefully, the binary representation of any power of 4 will contain only single one, followed by trailing zeros, even number of trailing zeros. So it will be 2 zeros, then it will be 4 zeros, then it will be 6 zeros. Okay, even power of 2 contains single zero, but the catch here is the number of trailing zeros is odd in this case. So for example 2, it is 1. For example it sometimes it is even, sometimes it is 1. So for 4 it is 100, so it is now odd. For 8 it is 1000, so it is odd. So we just have to check the special case where the number of trailing zeros is even. Okay, so we count the number of set bits, and while doing that, so I just take the index also. Okay, so if the ith bit is set at even index, then it is a power of 4, else not. So if return count equals to 1 and index mod 2 equals to 0, that means the binary representation of num contains only single one and followed by number of trailing zeros is even, then it is a power of 4. So let's take a count variable and proceed. Okay, run this compiler. Index, oh, I didn't declare index, so index equals to -1. Let's see. Come on. Okay, true, false. Let's submit. Today's late coding taking too much time to get the result. Okay, accepted. Okay, I will code this problem like this same solution in C++ without using this loop from 31 to 0, and it can be done by using two functions, built-in pop count, which will help us to count number of set bit in a number. Okay, and this function uh, uh, built-in ctz to count number of trailing zeros in a number. So it will give us count of uh, number of set bits. Okay, and this will give us count of trailing zeros. Okay, so if it is 1 and this function return mod 2 equals to 0, then we need to return true. Okay, so just comment this out and check. Okay, true and false. Okay, so let's submit. Accepted. Now the last solution we are going to discuss is because these two functions are present maybe in C++, it might be present in your favorite language, but I can't be really sure. So the last approach we are going to discuss is without using loop or recursion, but that will work in any of the language you code in. So it will be based on on using some maths concept and the inbuilt function square root. Okay, square root function is itself have a logarithmic time complexity, so the complexity of this approach is also be log n. Okay, so let's code this approach too. So if we look carefully, if a given number num is a power of 4, okay, so 4 is a power of 2, so we can represent 4 in 2 to the power 2 form. Okay, so if 4 to the power 1 can be represented as 2 to the power 2 whole to the power 1. Okay, and similarly 4 to the power 2 can be represented as 2 to the power 2 whole to the power 2. Similarly 4 to the power 3 can be represented as 2 to the power 2 whole to the power 3. And take one last more. 4 to the power 4 can be represented as 2 to the power 2 whole to the power 4. So if we take the square root of this, this whole thing, if we take the square root of this whole thing, it is like simplify it, like it will now be 2 to the power 2, it will now be 2 to the power 4, it will now be 2 to the power 6, it is now will be 2 to the power 8, because any number num to the power a to the power b can be represented as num to the power a into b. Okay, so we represent in this fashion. Now if we take the square root of this 2 to the power 2, if we take square root of this thing, okay, so it will be square root of 2 to the power 2 is 2. If we take square root of this, square root of 2 to the power 4 will be 2 to the power 2, it will be 2 to the power 1, square root of 2 to the power 6 will be 2 to the power 3, and square root of 2 to the power 8 will be to the power 4. Okay, so if in the end we are getting a number which is a power of 2, and which is a power of 2, then that the given on doing the square root, if we take the square root of the input number, and if that on taking the square root we found out the that the number is a power of 2, then definitely it's going to be the power of 4. But here is a special catch: if on doing the square root, if it is a perfect square, then we have to check. If it is not a perfect square, like we are getting some float value something, then it is then definitely it can't be the power of power of 4. Okay, so let's take the square root. Sq uh, equals to square root of the input number, and on taking the square root, and if this square root is a perfect square, then we have to check, else we have to return false. Okay, square root equals to perfect number, uh, and then is a power of 2, so it's a power of 2 also. So return uh, return if this number and num and num minus 1. So we can check if a number is a power of 2 by taking num and num minus 1. But 0 is a special case, so if 0 and it will return 0 false, and it will if and num minus 1 equals to 0, then it is power of 2. So on taking negation of 0, it will return false. So this, if it is a power of 2, then it will in the end return true, else false. So yeah, let's let's comment this out thing and submit. False and false. 16 is 4 into 4 equals to 16. Okay, so let's check first. Am I coming here? Let's scroll. Okay, 4. So 4 and okay, 4 and num minus 1. Oh, sorry, sq. We have to yeah, square root for a square. Okay, square root, and still we have square root and then sq and sq minus 4. Okay, so why it is okay, if okay, so if sq equals to 0, return false, else return sq and sq minus 1 equals to 0. Let's, maybe some precedence problem I'm facing. False. By let's output C out why it is sq and sq minus 1. What's happening? Uh, okay. What's happening? Okay, 0. So I guess return sq and this. Okay, I have to do this. Let's see. Okay. Yeah, I have to take in the bracket as well. Oh, input. So, okay, I didn't take the negative part. So if given number is less than equals to 0, then I just have to return simply false. Okay, accepted. So thanks for watching, guys. Let's submit one last time without comments. So uh, yes. Okay. So thanks for watching, guys.